Hi everyone, my name is Mohammad Faisal Sumro and my thesis topic is antenna design for 5G networks. My supervisor is Dr. Rad. I'll be talking about few things in this thesis topics, which you can see in there. I'm going to talk about the background of mobile networks, 5G networks, millimeter wave, MIMO technology, which stands for multi-input, multi-output. And then I can talk about some antenna designs and their simulations and results. And lastly, I'm going to talk about the conclusion and future works. Firstly, I will talk about the background of mobile networks, so how it got started and all that. First mobile network that came as a first generation, which is known as 1G. It rolled out in 1980s. It was the first ever mobile networks. The second one was the second generation, which came in early 1990s. It was the first ever digital systems, which includes services as SMS, and it had the low data rate as well. The next one was the third generation, which included technologies such as CDMA. It had the higher data rate as compared to the first generation and the second generation. It came out in the 2000, in the early 2000s. The next one is the fourth generation, which we are currently using it. It came out in 2010 onwards, and it had the high speed features, including video conferencing and live streaming. So what is a fifth generation, and why there's so much excitement in there? Fifth generation is the forthcoming mobile network, which has a lightning fast speed compared with the current fourth generation. The data rate is set to increase by almost 100 times with the current data rate, and the latency as predicted should be reduced as well. The cost of the 5G network will be reduced as well, and there will be more powerful and enhanced convergence. It is said that a millimeter wave is introduced in 5G network. Now I'm going to talk about what millimeter wave is. Millimeter wave, and it is an electromagnetic spectrum which has range between 30 gigahertz to the 300 gigahertz. The features include is increase in the bandwidth. It is known as millimeter, which has the smaller wavelength. The latency is decreased rapidly, which hence making the antenna size very small and productive. It reduces the cost as well, as the size of the antenna is really small, so you can fit in mobile and the base station. The most important topic of my thesis is the multi-input and multi-output technologies which will be used in the 5G. So basically, as is known as MIMO, which stands for Massive Multi-Input Multi-Output, which has gained a lot of attentions in the wireless communication, as it offers a great increase in the data and throughput. It basically uses multiple antennas to produce a highly concentrated beam, which can easily transmit energy to the mobile networks, and as predicted, has the high efficiency and reliability. So to move ahead with the 5G design, we need to implement and design a antenna so that it can fulfill the requirements of 5G networks. The antenna should be efficient enough to in order to fulfill all the promises that 5G has promised, and do in order to gain the desired results and speed and efficiency. In the next few slides, I'll be presenting few antenna designs that have been proposed throughout this research. The first one is the PCB grid array antennas, which you can see on here as well. It uses the fixed beam microstrip array on a 4R4 FR4 substrate. This antenna has predicted as the gain of around 12 dBi at a 200 gigahertz frequency, and as you can see, the geometries of the 28 gigahertz antenna. The next one is a T-shaped antenna, which has the following configurations. It is a simple and visible antenna, which contains advantages such as compactness and easy to fabricate it. It provides a good gain of up to 4.71 dBi, and it has a wider bandwidth. The next one is a S-band short patch antenna. As you can see, the configuration of it, and it operates at an S-band of 2.45 gigahertz, which is very small, hence making the antenna a much smaller, and it has a smooth radiation pattern. In my thesis, I have simulated few antenna design using a software called the high frequency simulator structure. I chose this software because it was easy to use, and it produces an accurate results and quick response. And the advantages includes the unmatched performance and in-depth analysis. So one of the designs that I simulated was a T-shaped antenna using the HFSS software. Just going through all the processes, the model was built successfully as shown in that. It has the return loss of around minus 24.5 dB at a resonating frequency as 30.2 gigahertz. As you can see, the radiation pattern of this design, which gives a gain around 7.38 gigahertz, and as you can see, it's quite smooth as well. The next up, which I simulated, was a S-band short patch antenna. As you can see, the configuration in there, which has the return loss of around minus 27.6 at 2.45 gigahertz. It has a smooth gain at up around 3.41 dBi. So that's what I was talking about the 5G. Many research have been started already in 5G networks. The 5G network is currently work is going on in that, and it's still a time when it finally rolls out in 2020, but researchers have started many fronts. It is important to meet the challenges of 5G networks and find the best internet design which with not compromise on quality and efficiency. The future works of this thesis, which will incorporate in ECTE451, will be redesigning an antenna with an improved structure, and also building an actual antenna in order to test the different frequencies and in order to reduce the gain as well. So thank you so much for watching.